Welcome back to the third clinic on today's May edition of NMRAx. I'm Speed at the bottom of the helix. Our next guest has been a professional 3D printer person and has worked for some biggest names in the industry. I'd like to introduce with what to do when the printer is brand new and on your desk, all the way from Tallahassee, Logan Zimmerman.
Hey, how you doing, everybody? Thanks for having me again. I really appreciate it. So, all right, in today's clinic, we're going to get into basically you have your 3D printer, it's installed. Now, what do you do? So, I'm going to go ahead and share a presentation with you all, and then in between the presentation, I have a couple websites and things that I'm going to help you guys like see how to navigate, where to go. We're just going to kind of start from literally you plugged it in, you don't know what to do, and let's go from there. Sound good?
Cool.
All right, let's go. All right. So we have uh, the first thing that you want to think about is the slicer program. And we talked about this in the last clinic. This is basically the brains of your printer. It tells your printer what to do. You import your files, you set them up, and it gives all the parameters for your 3D printer in order to help it understand what needs to happen. We'll go over some of the slicers configuration wizards because in order to use your printer, depending on the slicer that you have, there are certain parameters. Like not every printer is built the same size. They're not all the same in how the printer head moves. It could be something called a core XY, where the bed moves down, or it could be what they call a bed slinger or Cartesian printer, where the bed's moving in and out, and then the nozzle's moving left and right. So it's important that your file gives the correct instructions to the printer that you're using. So we'll go over the second point here, the configuration wizard, and then after that we'll get into setting up filament profiles. So there are stock profiles, but in my experience, certain plastics, like not every PLA loves the same temperatures, not every PETG, and these are the filament plastic type, like the names. That's what those letters represent. And so sometimes you have to dial it in. You might have two different brands of filament and one print's fine, but then you print with a different brand and it starts stringing and it leaves like plastic hairs or wisps all over your print. And there are things you can do about it. So we'll talk a little bit about that. And then after we have everything set up, well, you need to have something to print. So we're going to go over finding a file and or creating a file. And this is just going to be a very basic like touch on the topic, nothing in depth. Um, and then once you have the file, you need to import it into your slicer. And then you can double check like the orientation and the supports. And then once that whole print is set up, you do something called slicing. And then it will take all the parameters and create a G code file that you will plug into your printer. And your printer will know what to do as soon as you start that file that you select on the printer. And some of the important like pre-flight checklist kind of things, you need to make sure your build plate's clean, whether it's from the last print or even I had one of my printers came in from the factory. There was some kind of film on the plate, and I just assumed it's brand new. It's from the factory. I plug it in. I couldn't get prints to stick. Started doing all the troubleshooting of all the things that are proper to find out that the build plate just had something on, some film on it that I couldn't feel, and the IPA, the alcohol that I used to clean, it was just thinning the film. It wasn't actually removing the film. So we'll talk a little bit about that. And then the last thing that you want to check before you walk away from your printer in any capacity is making sure that the first layer is down. So I'll show you a couple images of what a good first layer looks like. But once the first layer is down and it looks amazing, you can pretty much let it do its thing from then on with no intervention. So this is kind of how to get from I plugged it in to I can verify what I need to verify to let it run for whatever the 10 hours, 12 hours, 14 hours it might need to do the print. So moving on. the slicer configuration wizard, and I'll go through some of this in the program so you guys can see that. But this is a screen that you will see in Prusa Slicer specifically. You can see here that it says Creality FFF Technology Printers at the top. And this is like the Ender family printers. What you would like to do here is one, find like, do I have an Ender 3, Ender 3 Neo? Like, what is the specific model number that you have? And if the profile exists, you select the profile. And then a very important part also is what nozzle are you using? What nozzle does it come from the manufacturer with? Did you buy a nozzle that you want to specifically use? Maybe thicker plastic for a little stronger parts? Do you want thinner plastic for better resolution on your parts? You need to select that here so the profile incorporates how thick. It needs to know how thick the plastic that's going down is to do all this calculation. So if you change your nozzle yourself or your printer doesn't come with a point 0.4, which is the typical point 0.4 is a very standard nozzle, but some printers like the Prusa XL, they come with a point 0.6 nozzle. So you need to make sure you know that. So that'll take a little investigation, but like 90% of the printers out there, they're going to have a 0.04 millimeter nozzle. So you're most likely okay just selecting that. But once you select your printer type, your nozzle type, all the devs, if the profile is already existing here, they've already calculated how big is your printer, how fast is it supposed to move. So all that advanced level stuff is taken care of for you. So the filament is the next thing that you have to set up or configure. So now your printer's set, right? You use the wizard, printer's good to go. Now you want to make sure that you look at the plastic that you're using. And on the box, it's going to give you kind of a range. And on here, you can see generic PLA. When you select it, it gives temperatures circled in red over here. And this may or may not be the correct temperature for your filament. I found that on my printers with the nozzles that I put on them, these settings, they lead to a little bit of that stringing, and I don't like the stringing. So what I do is I lower the temperature about 10 degrees Celsius, and the strings go away. And so what you'll want to do is, some of this might be some trial and error. You'll use your printer, make a print, a test print, and see if there's any stringing. And there are things that you can find online that are calibration prints. Like there is a tower test that will show if your printer's stringing that you could print and then verify if you need to pull this down, or you just print the thing that you're trying to print and on the first run see if it comes out how you like, and if it doesn't, adjust from then on until you get the parameters that you want. And the thing is, that's early on only going to happen a few times. If you're using the same filament, you're using the same printer, eventually over time, you'll learn like what your printer likes, what your filament type likes. And once you've kind of got that sorted out, you shouldn't have to change it for a long time, like, or if any at all. Once you have your temperatures set to the proper temperatures for your filament, you don't need to, but instead of having to come in here every time and change it manually, you can save your file in Prusa Slicer with this setting here, the save icon, and then you can rename it to, I use Amelin printer filament, so this is the Amelin PLA or the Overture PLA. And then once you've kind of ironed out the temps, now you can just select from this drop-down menu the specific filament with the settings that you've dialed for your filament. One thing that you do want to think about too is the first layer bed temperature and the other layer bed temperature. Honestly, this is way more stable than the filament settings themselves for the temperature of the plastic. So you won't change these too much, but if you're having some kind of layer adhesion problem or some issue that can be attributed to the bed temperatures, then you may want to play with those settings. But again, we're kind of trying to you shouldn't have to do this. So sometimes I do asides that are like, oh, just in case, think about this. We want to make it easy as possible. So for now, I would do a test print and then only change anything after your first print if it didn't come out exactly how you like. Now we need to have a place, we need to have a model, we need to have something to print, right? So on printables.com, we can come over here and find something to put into um, our slicer, whatever the thing that we need. I'm going to go ahead and come out of here, and hopefully you guys can see everything. Now on printables.com, you can see this found a train front here. Just wanted to make sure to point out this is not my file. This person here at J Kinch, I'm not even going to try to pronounce that last name, but this is their file, and it looked like a file that kind of fits today's theme, right? So you would want to come here to printables.com, type into the search box right here whatever you're looking for, train related things. If it's not train related, maybe there's some type of electronics that you have that's a very standard piece, something from Arduino or some, maybe you want a box that somebody's already created for some circuit boards from Arduino. You can type these things in and look up here, and then you're going to download your file, and then what you're going to get is an STL, and it's a 3D representation of the physical thing you're going to be printing, and it's going to show up here. And when you download it, it's going to come into your downloads file, and so you'll just have that tucked away for later, so that way you can import it into your slicer. But yeah, for the most part, printables is that easy, right? If you want something, you type it in, you look it up. Now, not everything under the sun is already designed. So we'll do trains, right? But you all are a very niche and detailed community. And I think a lot of these files on here are more like, you can see, like, oh, these are like kids, like the kids train set. Oh, somebody needs a piece that's missing from a wooden rail train set that they have for their infant to push around or something, right? So you may not quite find exactly what you're looking for. And in that case, and actually, as an aside, my hope is that at some point I can get enough of you all interested that if some of you become makers, designers, that these repositories will start being filled with things that matter. So like this guy, he has it right here: HO scale trains, train track shelf. So this is something like specifically for HO. So you just kind of have to look around and see if you can find things that work for your exact need. Now, if you can't find something that works for your exact need, what do? You come over here and you have Tinkercad. I don't think I really need to show you guys the slide, but we will continue with the slideshow, tinkercad.com, right? And so we can look at these different files. You can create things here. And just to show you kind of like a demonstration, this is something like, let's say we're going to make a badge or a logo. I found this SVG. It's a free vector. Again, I want to make the attribution to this person here, Aji Peppa Brianna. They made this vector file. And if you go to the free download, you can see there's an SVG, and Tinkercad will let you import SVG files. So in here, to get this file, all I did was import, choose a file, and then you can grab this SVG. So if you already have logos for like your train clubs and you guys want to make something, you can just use the 2D image that you already have designed, as long as it's an SVG file here. And then when you see it imports nice and large, we're going to shrink it down a little. And a neat thing they just added that they didn't have before, that I'm glad they have now, is this quality. So this is actually new. and it kind of tightens up the lines. But the thing you can see here is all these hollow areas. That's nothing. Only the pink is going to be the plastic. And so you may want to find out. So if I have this at, basically 190, I can make a backing, and we'll talk about that just real quickly. So if I just wanted to make like this as a little logo, I'll come in here and I'll grab a cylinder, and then I'll turn that cylinder to the same size as what I have here. All I did was type 190 into the other box there, so that way they match. Smooth it out with the sides function. Maybe I want this whole thing to be 3 millimeters, so I'll do that as 2. And then, yeah, that was pretty close. So I'll do that as 3. And then now I can do something called an alignment tool and align these. And right now I'm just showing you guys, right, you're going to have to go in and play with this and figure out how to do these things, look up tutorials, but just so you can see, right, that we have some kind of, let's see, change the colors. Let's do presets, make that black, make this white, or like a light gray, so the steam, I don't know. But now you can take this and combine these shapes and give it a second to render. But once this is done, you can take this file and you can export it. So now it's finished there. Now right now it's showing as one object, so it's selected a color. If I wanted to come in here and go multicolor, it'll show that it's still 2 different layers. But I've created a thing, and for the sake of time, because we don't have a ton of time to do like a lecture based on this, but I've created a thing, and now I can export that thing as an STL file. So remember that STL, that's the most important file that you want. They do have OBJs, but if you're using that program, the OBJs actually, they come zipped, and then you have to unzip and extract, and it's extra steps. So if you just do the STL, you can get the STL file. So real quick, we'll get rid of this guy. I just made a file. So right now I have the file that I made and the file that I downloaded. So you have train font is the one that we got from the repository online that somebody else created. And then whatever this name is that Tinkercad gave it is the logo that we created. So if I want to pull in the logo, you can see here that it is now pulled in the logo. So this is what the 3D printer will create for us. And then we looked at it as a two-tone thing. So you could even, if the layers stack on top of each other, you can make multiple color prints by setting a color change in the slicer software. So let's quickly kind of go over our settings that we talked about earlier. I have 0.2 millimeter layer height, which is a pretty typical layer height that works just generically for everything. If you want to do it a little thinner, if you have a lot of curved objects like the file that I'll pull in a second, you might want to do it a little thinner or do something called adaptive, and we'll touch on that in a second. But if it's a very simple, like flat piece with 2 colors, and I just want to make a coin shape like this, what I would end up doing is 1, verify quality, 0.2 works. Infill, 0.15 works for just about everything. If you want a little bit more weight to your item, or you want to make sure that the top layers are covered a little bit better underneath of the like on the infill. I'll show you the infill in just a second. It'll make more sense. I can change this to 25%. If I slice now what the infill actually is, since we're talking about it, I'll go ahead and show you. There's a grid pattern that hollows out your object a bit. So that way you have, you're not using completely all of your filament. So it saves filament, it saves some weight, but you can see these little grids here. that's what the infill is. And if I change this number 25%, 15%, and then I have to reslice it to get my preview back. But you'll see that the gaps increase. And so 15% works, but you can see it's less dense. So this is kind of preference / maybe next level. You shouldn't have to worry about it right now. 15 typically works for everything. And a lot of the stock slicer settings work for most things. So again, to simplify it and make it easy, just print with how your profile is set up and print with what the manufacturers have already established, and only change it if it's not working for your process. So right here, we verified we have 0.2 millimeter quality. We have an infill that we like. There are print settings under this menu. Again, unless you have a need for something, you don't need to change any of these. The one that I do change frequently is the perimeters value, and that's only typically if I'm doing smaller objects. So things that are going to possibly be brittle, I'll add a couple more perimeters, and then that will strengthen my print. I'll show you what the perimeters are. So in this example here, there is a solid piece of plastic that outlines the entire shape. So if you see, we zoom way in here, there's an orange and a yellow. That's 2 perimeters. If this was a skinny object and I wanted to make it stronger because I'm worried about it breaking, as I add perimeters, you will just get more of these rings that surround the perimeter of the object. So just as an aside, if your prints are breaking, add more perimeters. It'll help. So we're going to come in here. We're going to try and find out. Okay, so we wanted gray to be the first layer here. And so we'll leave that as, let's say, the gray color. And then we're going to do a filament change right here. Do that one. And so now you can see we'll do this other filament as black. And this is just so you can see the difference in the colors here. So now these are just previews. The real color that you have is going to be based on the plastics that you're using. But you can see for this logo, just as a 2-color concept, I have 1 color on the outside for the background, and then I have the actual like SVG portion of the file as black here. But this is just to help you distinguish between where the color change is, and then you can select, like, maybe you want this to be white and this to be black, or this to be red and this to be gold. Whatever plastic you have is what you'll do for this. But if you look through here, I've taken an STL, I've given it 2 colors. You can do this on any printer. That's why I'm showing you this. So if you want to do a multicolor thing, you can very easily just select that little plus button here, and it says we're adding a color change, and then now you have a 2-color logo. And as long as you stack it, if you ever have looked up anything about screen printing, or you understand how to make logos and you know that there's layers to it, that's all this is we're telling the printer where the layers are, and that's when we're changing the colors. So you could theoretically do this as 3, 4, 5 colors. If you know how to do like Adobe Illustrator work, all you're doing is whatever layer the SVG was, you set that layer in here, and then it gives you a multicolor print. So now let's take a look. So this is just to show you the concept of importing your file that you created, and then where we want it to be a multicolor in this example, but it doesn't have to be. You could paint fill this. You could do this as a single layer, get rid of this thing, go back to that layer where it's switching, delete it. And then now this is a single color, no changes. It's just going to print this as is Any of the yellow and orange you see here is just in the legend. You can see, right, perimeters. You don't have to worry about any of that. This is going to be a single color. But what is important to know is that on these layers, right, there is a height to it. So right here is where the first like train image stops, and then it starts building on top that different color. So if I wanted to paint fill this, the smoke in the train would be recessed or embossed, and then I can put paint inside of it, fill it, wipe it with uh, IPA, acetone, whatever works best to clear your paints off, and then the paint stays inside, and then you have the plastic color on the outside, and you could paint fill this object if you wanted to. So think of 3D printing as a tool, and let your mind wander, and get as creative as possible. So now we've looked at the thing that we created and pulled in. Now we're going to go to the thing that someone else created. So I'm going to go ahead and use this plus button to add a file. And then I'm going to grab this train front. Now this train front comes in the way that whoever designed it oriented it, right? This is how he exported it from his design software. And you may or may not like how this prints. And if I look underneath at the bottom, the only part touching the build plate is this little tiny front here. I don't know that I like that so much. So there's a couple things you can do, and this is where the orientation of your print matters, is we come in to a rotation, and you have these different colored axes that you can rotate the print. You could spin it around with the blue. With the green, you can tilt it on its side. Or with the red, is what we're going to do. You can snap it on its back. So I'm going to make it 90 degrees. And then now, even though it's still not a ton of a footprint, I do have a nice U shape here. And there are settings like brims and things that you can add to kind of hold this U shape down. But we look from the side, everything stacks nicely kind of on top of that U shape, versus this little piece here, nothing stacked on it. Everything went out kind of like as a lever, which would potentially make the print, as it got heavy and away from the place that's actually on the build plate, could possibly cause your print to delaminate, or one of the layer lines to separate, or something that you don't want. It's not ideal. One thing that you have to keep in mind as well is when we slice this, the printers, well, already have the support set up here. The printer would yell at us if I didn't have these support structures here. Now, these are just little temporary pieces of plastic, so you need to know what supports are, because you're going to have to use them at some point. You can't avoid it completely unless you're designing yourself and you make things modular, then maybe. But these are all going to get removed. So once you print your file, you're going to rip all these off, and what's left behind is going to be what you actually care about in your model. One other thing I wanted to point out is when you're slicing, this slider is going to be your best friend. When I'm coming down here, you can see all the individual slices and cross sections of what the printer's doing, right? So if I look in here, right at the nose, this is where that kind of 0.2 I mentioned matters. You see how there's all these little steps that are coming up here? That's kind of unavoidable right now in 3D printing. Round objects, since we're doing 2D layers stacked on top of each other, round surfaces at the top can end up with this like little stair stepping thing. So the two things you have to think about: is it acceptable? Do I like the way it looks? Is it something that I'm okay with people knowing it's 3D printed? Do I like the aesthetics of it being 3D printed? And if you don't, and you want it to be completely realistic looking, then you have to start thinking, okay, well, am I fine with sanding this away? And if I want to make my job easier for that sanding process, maybe you have to think about doing something like the quality or detailed setting, I'd be careful with the detail. I print at quality for the most part. So now it's asking me if I want to transfer my support material settings and all of that over when I go to detail, and I do. So once I switch this to quality, you can see the stair step is lessened. Like or I should say, there's more steps, but less of that effect. The effect of the stair step is lessened. So by changing these parameters, right, we can see how it affects our print. So I'm going to do all three. Now I made it larger. Now you can see it's even kind of more pronounced, right, when I went to the 0.3 on draft mode. So there are things in the slicer that you'll want to play with. And again, I use play with on purpose. Like, you're going to want to print, test, repeat, and kind of learn the art that is 3D printing. It is a machine that is supposed to reproduce the things that you design, but something you have to think about is, like everything else in your hobby, it took time to master something, and so it will take time to master this. But 3D printing is a good starting point for, maybe you don't want to model this entire thing. Let's say you're making it out of foam, or I don't know exactly what the greatest analogy is there, but if you have to sculpt something or cut these out and shape them, how much time does it take? Versus if I need, 3 of these, I have my printer print 3, and then maybe I just have to sand these layers away. So just something to think about. So in our settings, we have ways to control quality. We have ways to control all the settings for the time it takes to print, the temperatures for the filament to avoid stringing, supports to make sure everything comes out as expected. So these are all things that you have to be mindful of. And then when we're in here, just make sure also, when you're pulling these supports away, you're going to have some little things that you may have to clean up as well, that are like these little pock marks on the surface, or bumps or things that you'll have to remove. So just something to keep in mind. All right, so real quick, let's see how far ahead in my presentation I jumped. And we'll go back and check that out. All right. All right. Yeah, so strength on these models is another thing. Resin and the FFF, which is what we were just looking at with the layers, they're a little bit different. So orienting the parts in certain ways will allow you to get the maximum kind of quality and strength properties. So these are things that in resin you can print in almost any orientation, because resin is isotropic, which means any direction that the thing is manufactured, the strength is equal. On any piece that you're looking at, the strength of it will be the same, uniform. Whereas in this example here, you can see that it has layer lines. Well, layer lines are basically plastic welds on top of each other, which means the layer line is kind of a weak point compared to, like if you look at the yellow lines, see how it's a continuous string of plastic? Anything that's a continuous string of plastic that you see is very strong. But the layers that lay on top of each other, they're only as strong as the bond from layer to layer. So you may need to orient your part to maximize the strength of something that's a thin feature or a thin wall. So again, print the thing, play with it, try to break it. If something breaks easier than you expected, or you're in here sanding and you snap something and didn't realize it, go back into your slicer program, orient your model in such a way that the thing that broke won't break, by making sure that that feature is printed with long strands rather than layer by layer. When we slice, the settings on the right that we were looking at, it will show you how much filament you're using. So this is good for two reasons. One, how much filament do you have in stock? What do you have to work with? And two, what's the time frame? What's the cost? You can kind of break down the cost. You can even put in here, it has a cost estimator. You can put in your profile how much your filament costs, and then it will calculate based on what you used, what that cost you. So sometimes you may look at a job and you could pay someone else to do it. You can buy it online or you can do it yourself. You can kind of use your slicer to also gauge whether or not you even want to take on a project. So I'm going to go to the resin real quick before we go to cleaning the build plate, because this is now getting into what you should do after you've saved your file. So we're going to go back here into the slicer. So now that I've sliced this and you see this profile here with all these slices, you're going to want to export G-code. Once I export the G-code, it's going to pull up my downloads folder or wherever I need to put it. What I'm going to look for, and I don't have one installed right now, but down in here, you'll have your SD card for your printer, or if you have a networked printer, you can send it straight to the printer. They're getting much better these days with printers that have networking capabilities, so that way you can see them. So you'll just select in here where to send the file. Once you save the file, it's going to export that to your printer, and now it exists on your printer's interface. So you're going to want to go over there and either run it remotely from your computer, or I have some older printers, right? I'm going to walk over there and select the file and tell it to go. So once I have all of my settings here, right? We didn't go over support material, but it's important, but we don't, like, there's a checkbox that does generate auto supports, and it works. And there are ways to do, like, maybe you don't want as much support as you have here just everywhere. You can delete those, but again, we're talking about just getting started, getting prints. You can play around with like paint on supports and things like that, and you can find a way to lessen this so you have less work manually, but that's getting into intermediate. But we have our modes selected for the detail that we want, speed, quality, what have you. We have our infill selected. We have our filament settings here with the temperatures. I showed you a screenshot of this, but you can just come in here and lower the temp, or you can type it in, right? Whichever one works for you. And once we have the temperature set, all of these settings that we talked about with the quality set, the infill set, you slice it, you save it, it's on your printer, you tell it to print. But before we send it over to the printer, the thing that I want you guys to pay attention to is that we need a clean build plate. And a lot of people overlook this. If I do a print and it prints well the first time, and then I do the same print again and it prints over, there's little bits of the plastic that may be left behind as a residue. There's over time, like, the adhesion just lowers. So typically between every print, I use isopropyl alcohol and I wipe the surface clean. But also, as you can see here with the red arrows, in your slicer settings, there's going to be a purge line, because you need to make sure there's plastic in the nozzle before you start printing. And then there might be some kind of draft shield or brim or something that's going to be, or skirt that goes around your print early on, and you got to remove these before you just send a print to the printer again. So if you do have a network printer, this is even more important, because you're not standing in front of the printer when you start it. You need to make sure, right, that you go remove the physical things off the printer so your next print is available. You may have seen this Dawn bottle here. Again, I've tried to tell people, like, in the industry, I've been helping people, and they're usually like, I'm not washing my build plate with Dawn soap. I'm sorry, but this works, and it works really well. And some people, I don't know why, like, oh, all the manufacturers say use IPA. IPA will thin certain residues, not remove them. If you use a dish soap and you use a non-abrasive, sponge, you can give it kind of a deep clean with just a little bit of soap, and it will remove and rinse away all the residues and start your printer from scratch, or start your build plate from scratch, and you'll get great adhesion. Even if you have a clean build plate and you're getting good layer adhesion, sometimes the bigger your print gets, so you see this is a fairly small print compared to the build plate. If this skirt and this print was the entire size of the build plate, there's a good chance the corners will lift and we'll get some kind of warping because it's a thermoplastic. When it heats up, it expands. Over time, because these are 10, 12, 14-hour prints, the layers start to cool down. And as the layers cool down, they shrink. And as it shrinks, it starts putting tension on the corners. And if the corners lift before the print's finished, it won't solidify in the perfect shape that you need it to be. And that's where our little friend here, the 3D lac, comes into play. This is an adhesive. It smells kind of like hairspray. It's better than hairspray. Some people have used hairspray, but for the most part, whatever your trouble area is on your print. And again, this is one of those I've printed, I've tested. This thing's just being tricky. Just spray some of this on your build plate in your golden. It'll hold the corners down. So, but you have to be careful. It might discolor the surface. So whatever's down, if that's a hidden feature, unless sometimes I print things face down to get the build plate texture. If it discolors, that's not a good thing. A little sneaky trick about 3D prints, let's say you use a black filament, you have your adhesive, you pull it off, it's going to whiten the surface of the plastic. You can take a heat gun and very briefly go back and forth passes. It'll return the color back to the proper color. So that's just one little tip if anybody needs that or has ever wondered, like, hey, I pulled a print off, the color's discolored. You can use a heat gun to bring the color back. So make sure your build plate's clean. Make sure it's free of the previous prints. Now you can go to your printer or go to your network and select print and tell it it's all systems go. Now, once the printer started, this is kind of the last thing on your pre-flight checklist, is you need to make sure that you have a good first layer. And you'll get an eye for this. And once it's dialed in, there are offsets on your printers that you'll use to kind of get this layer perfect. But once it's set, don't touch anything. Don't manhandle your printer and make anything shift around or move. And you won't have to set this again. Printers do have, especially nowadays, it's more common to have a bed leveling sensor, but you most likely still need to do an offset to just kind of get the layer perfect. Now, if you look at these three photos, you can see very stringing, like the plastic, the strands are individual. The sides of each strand haven't overlapped enough to stick together. So they're all separate and stringy. But if you look in the middle, they've compressed the perfect amount. The little white lines in between you can see, that's where there's a bond between layers sideways. And then if your print head is too low, you see these little kind of flares of plastic. It's squishing too much. So like if you took a piece of Play-Doh or putty and pushed down in the center, what happens? It's going to kind of curve up and around. That's the same thing that your plastic's doing here. And so what you're shooting for is to get your first layer to look like this good layer here, and it's solid. Another way to look at it is across your bed. You see this rectangle here. Somebody either did the offsets different in the middle of this, most likely what they did, but some of, especially the cheaper printers, if you want to save some money, you may end up with a slightly warped bed. Now, the sensors are making this kind of a thing of the past. But if you do see something like this where one part of your print is stringy, one part of your print is perfect, one part of your print's too low, you may need to physically level your bed or check your bed leveling sensors. But just for a visual, take a look at that. You can Google perfect first layer or something like that, first layer 3D printing, and it will give you images that look like this. Now, once this is set, you're kind of good to go and ready to let the print continue. one last thing I did want to show for the resin guys with the last 2 minutes that I have here is in the resin slicer, you're going to have supports that look like this. And with resin, what's important? So the temperature was a thing in the layer heights, right? These all exist in the settings here. So you have different layer heights, and you can pull up with resin, usually the manufacturer's suggested settings for these, and just plug them in. But again, you're going to want to set the layer height, which will dictate how fast or slow, how much detail or low detail, but the light exposure time. This is the thing that you're going to want to play with resin prints. So if you're doing resin prints and you have a bunch of fine details, let's say like fur on a fox or something, or I don't know, a wolf, right? And you're not seeing the fur, it just looks kind of muted. You probably have too much light, and so it's overexposing, and you're not getting your details. And you'll want to turn that time down. Maybe instead of 2.5, you go to 2.3 and print again, and go to 2.1 and print again, and then you pick your favorite. And then there are calibration test prints that you can find that help you dial in these settings. But I just wanted to point out real quick, with resin, you're going to want to look at the light exposures and their corresponding to layer height. If I increase the layer height for a faster print, I'm going to want to go ahead and increase the time of exposure as well. So good luck, everybody, with your prints. I know I couldn't touch on everything specifically related to 3D printing today, but I was trying to kind of give you that first pre-flight checklist, like what to think about, settings that you want to have, and hopefully this was helpful.
Thank you, Logan. Ready for some questions? Can you hear me?
Yeah, you were asking me that.
Yes.
Yes, I'm ready for some questions.
Do any of these tools that you've showed cost money?
The softwares do not, unless you want like a pro version. The Resin Sheet 2 Box Pro does have an annual subscription, but other than that, the printers and filament obviously cost money, but the software does not. Tinkercad does not. If you want to do a like a high level CAD and you're really getting into CAD design, Fusion 360 has a hobbyist membership. But if you're, let's say, want to start selling your prints, if you make more than $1,000 a year, then they want you to have the paid for pro version.
Okay. Do you have any recommendations for infill design for printing buildings or rolling stock like we typically do?
Okay, infill as in like what I showed you.
Yeah, I believe the stuff that goes in between
Yep.
the
So
solid.
basically on the infill, it depends on a couple things. Because you guys are doing models, I'm going to say no. If it was something that needs to take some kind of impact, then maybe gyroid's not the best. Maybe you want something that's a little different, like a honeycomb pattern or something like that. But also time. Certain infills take longer than others. So if you have all the time in the world and you have a favorite pattern, wait for it. If you want it to go faster, there's gyroid, there's lightning, there's a few that take less material.
Cool. You skipped to a future question there, but how about generating auto supports?
Okay, auto supports usually suck, but in the instance of beginners, it's going to get your print most likely a successful print. As you start doing manual supports, you'll get less cleanup. It'll take less time to print, and you have to dial it in. You have to know what you're looking for. So there's certain things like overhangs. You don't want to go past 50 degrees overhang without maybe running into some trouble. If you're doing textures on the outside surface or lettering, you don't want to go past 0.5 millimeters extending from the exterior shell, or the plastic will start sagging and drooping and you'll need supports. So if you know that these things exist and what they are, you can go in and put the supports manually. And even working professionally, I'd work with some designers that were like, I don't want to waste my time doing it manually, but then they'd waste more time cleaning it up afterwards or something, right? They take 45 minutes to set it up once, and they could print 1,000 of them
Correct.
and save time. And put the time in to learn manual supporting. You'll thank me later.
Any recommendations if my printer does not have a heated bed or a bed that can control the temperature?
Mm, just yeah, it's going to limit your plastic that you're
Yeah.
allowed to use, the plastic profiles.
So maybe ask for another printer for Christmas.
Yes, that would be probably the best solution.
Because I know from my experience that that bed temperature thing and how far away your layer is from it, and if the box is enclosed or not, is a huge part of
Hmm.
the investment of time in this, especially the first layer. The first
Yeah,
layer has to
is
stick.
yes, it's
So,
everything. It's everything.
okay, so once I made something on a filament machine that broke between the layers. Don't
Yes.
remember the material, but how do I prevent that?
Okay, so you have two things. Do you want me to share my screen on this to
Sure.
show? Okay. So we'll go back into this. We will share the entire screen. All right. So let me get rid of these supports so we can look at the model. All right. So the thing that I want to look at here is you see these walls, how thin they are? These walls are going to snap most likely because the layer height or sorry, the thickness of it isn't very good. These little tabs, they're going to snap, right? So
Hmm.
what you want to do is maybe orient it. So the two things you can do is orient it so that way maybe it's more of a diagonal, right? You want to increase the length of the piece that's snapping. So the length of the layer. If I had a cylinder here, that would make it a lot faster, but you can do it in the design also. So real quick, and sorry, I'm gonna try to make this like quick. Um,
We got time. No, no hurry.
Okay, so two things. There's one little trick that you can do with 3D printing. So let's say I have this thing, and whatever the size is, we'll leave it 20 so you can see what I'm actually doing. But let's imagine this was just a thin feature, like an antenna or something, right? And it's real thin and it's going to snap. Uh, the two things that you can do. One, if I orient it like this in the slicer, like we showed, and maybe I have to flatten this little corner out so it'll stick and put supports, but you can see that the layer lines have become diagonal and they've lengthened. So now you have more layer adhesion. If you don't want to do that, one of the tricks, and you can even hide this if you want to. Let's get that there. Let's make this 15. So you can actually hollow out the center. So you remember when I talked about perimeters?
Hmm.
What you can do is basically duplicate the perimeters using your design. So if I do this and I actually hollow this feature out, what the software is going to do is it's going to put 3 perimeters here on the inside and 3 perimeters on the outside. So
Correct.
basically what you're doing is creating a space and tricking the printer into doing like 100% infill just on
Okay.
this feature.
Okay.
So that's what the trick is there. So one of those two things will work, and if it doesn't work, the last thing I'd say is if you hollow it out, maybe you could buy thin like carbon fiber rods or something and epoxy them in, and then it won't break. Or if that's too much, you might have to move to resin if it's still not worth it.
So by hollowing it out, you avoid the infill part and make it stronger when it breaks.
Yes, because if I let's say export this, sorry, I'm taking you guys on a journey. We're gonna open this guy. So um, basically now when I slice this, what you'll see is that you have 2 layers of, so there's still infill, right?
Hmm.
And you can see it's still hollow, but if this was solid, that infill would go from the second ring all the way across. But
Correct.
because I added that hollowed out, you have 2 perimeters. And then if I go into my settings and I increase the perimeters and I slice, now look, 100% infill.
Cool.
So you can just design it so that way that feature has the 100%, and all the rest of the model is still hollow, still time friendly for printing. You don't have to waste all your plastic on 100% of the model, just the feature that you're struggling with.
Cool. So then here's the question, the future question. What materials would you recommend for model airplanes? The
Ooh.
things that needs to take an impact.
Okay, so for a model airplane, they do have an advanced filament. Color Fab has something called a foaming. They have foaming PLA, they have foaming TPU, and what it is it has a blowing agent in it that with heat it creates bubbles, air bubbles inside of the
What?
plastic. Yeah, so I have some of that and I've played with it. It's crazy. It takes advanced settings, and thankfully some guys online have already been like, oh, if you print at this temperature and this speed with this offset, right, they've already done the homework for us. Like CNC Kitchen, I think, has a video on it. So something like that will lightweight your part, but then now you can use something with a high layer adhesion,
Okay.
to be a shell, or you can use an advanced, like there's modifiers that you can use in the slicer. So let's say I'm doing the wing. Maybe I put an object as a modifier that the center of the wing is foamed for lightweight, but then the shell of the wing, I tell it 100% infill.
Oh
So
wow.
so now I have kind of, you're using a similar amount of plastic, but instead of having little holes all through the infill, it's just little bubbles everywhere, but you're getting a full support of that shell.
Cool.
So I would say mainly find impact resistant engineering type plastics first. Um, but if that's not the case and you want to use PLA and it's more affordable, maybe find something like the Vario Shore and do some kind of hybrid model, that, or use the 3D printing for the bones and then learn carbon fiber layups or something. Like, I don't
Cool.
know.
It's just amazing all the different kinds of materials when they started doing the wood impregnated plastics
Yeah, yeah, yeah. I love
uh,
that. I
and
have a bunch of rolls of that. That's fun stuff.
yeah, I love this smell of cut wood, like
Yeah.
a wood shop. I
Hmm.
just stand there and just inhale the whole time. So I actually sniff the, the wood impregnated.
So if you like scented filament, there are some companies that have like a coffee scent. There's a company that did like a beef jerky scent. So
Wow,
it smells like steak when you're cooking, or smells like coffee when you're printing. So there's some companies having fun with it for sure.
there goes the stock train. Okay, last question, and thank you very much for your time. Is where do we go for help?
Oh, so there's YouTube. Um, there's tutorials from the manufacturers themselves, and then I have my new website that is created, and I'm getting into it. You guys can reach out to me through multilayeredconcepts.com, and that's multi-layered. Sometimes multi-layer people type in and it says not found. He's got a fake business. So, but yeah, if you go there and send an email, it'll come into my business inbox, and you know, I'll do what I can, but I definitely have a lot of stuff to stand up to continue on this journey.
So what could you show us next?
Like on a next clinic.
Yes.
Well, there's two things that come to mind. One is maybe like a troubleshooting cause and effect. There's material sciencey type thing where I can do a couple prints and say, okay, like here's TPU, here's a flexible filament, here's a rigid filament, here's I don't know. We don't need to do any smoothing of ABS live. I don't need to get chemicals out and stuff. So, but yeah, I don't know. There's or people if they want just an intermediate. There's design. We can do Tinkercad thing. I don't know. I'm up for whatever. I just like talking about this stuff, man. So
Thank you. We will definitely be in contact.
okay.
So thank you for those of you that hang out with us this morning. Our next NMRAx will be on June the 29th, which is again the fourth Saturday, and it will be also in the morning New York time. So hope to see you guys then. Be safe.